Hey, Rani here. Shall we make a game? Now, I was planning on doing some other stuff in this game today. However, that stuff would have required me to do some stuff off stream beforehand, and time is always against us, as I say. Now, we are 14 days into this, so we're nearly a quarter of the way in, and we don't yet have dialogue in our sort of point and click adventure game. So that's something I'm hoping to get done today. However, first of all, I need to finish something that I was starting out last time, which is camera shake. Right, so let's, where are we going to find this? I guess I'll make a new folder for it. Yeah, so I was going to test whether we can do a nice simple just rotation of the camera on top of the matrix we're already generating. So to test that, I'm just going to comment that out and then make sure I can make. Oh, I just need to get rid of this variable I've defined now I'm using. So yeah, I'm going to get the camera basically just going around in a circle around the room, just so we can get an idea of like whether this new functionality is working. So yeah, we can pull the camera up to there nice and simple. And then I'm going to modify the fixed camera here because this is currently our code for doing a fixed camera. I am just going to get rid of all of this. And temporarily, I'm going to make this do something very illogical. It's going to ignore all of the inputs, and we're just going to generate some rough inputs. So we need to track how many frames we've had. Pull in the math helper. We're going to need some trigonometry for this. And yeah, that should be fine. I'm gonna need that. Okay, this should have the camera kind of spin around in a circle. Or it could not. Oh yeah, I didn't actually, because I'm using a number here to track the angle from which the camera's viewing, and then I'm not actually altering it at any point, meaning that it's just sitting there. So let's make it spin round. Okay, that's working. Oh, that's actually making me weirdly sick. I hope it's not having that effect for everyone else. Let's push the camera back into the room a bit, and I think I might have the rotation the wrong way around on this. Oh no, that's right, yeah, so it's basically rotating around the point and looking into the room. So I'm going to slow that down a bit, as I think that's part of the reason it's making me so sick. And bring the camera back into the room. Let's massively reduce the kind of like rotation, the sort of like orbit radius, as it were. Okay, there we go. Hey, it's kind of neat seeing the cutscene from this angle. I'm just going to raise the camera up a bit more, just so we can see a bit more of the room, not clipping through the TV and things. And then I'm going to put my sort of, yeah, it's a good angle. And then I'm going to basically just put in my sort of like hacky sort of camera shake in, see what happens. And we're going to want like a fraction of this, so actually we're going to want like that. Right, let's try and rotate a bit. We're going to make a rotation matrix to kind of like stick on top of the camera matrix we already have. Oh, we're going to actually import the transform stuff in here because we haven't got it in here yet. And then it's not going to position it, it's just going to rotate it. So we'll just take the sine of the angle that we're feeding into it. We're probably going to like make it a really small motion, you know, 0.1 radians. It'll probably be enough that we'll be able to see it, but it won't make us violently sick. And we can then multiply that into our camera matrix. Who knows whether this will work? Oh, yeah, you can't have an unsigned float. That makes no sense. What am I doing? Okay. So as you can see, it's meant to be a backwards and forwards rotation, but it's being done in world space at the moment, meaning that it's actually, it's like the room is shaking rather than the camera. So I'm just going to try swapping the two arguments around here and see if we can apply some rotation this way. The answer is no, because now we're messing around with the view frustum, which isn't what we want to do if possible. Do I separate out the two halves of the camera so I can stick this between? Do I add a simple thing in so that we can have the rotation applied in here? I don't think so. I mean, every camera would have to be aware of shake, and ideally it'd be kind of like central. Let's make some separate matrices. And then we can kind of combine them together sort of here. Yeah. And too many matrices. All right, I just need to put some remarks in here, like, because it's stating what they're all kind of for. There we go. Just so it's clear when you're working with this this header file exactly what these are all for, because, like, you know, it wouldn't be obvious that some of them would be written to and some of them would be automatically populated. And yep, that's good. And all right, I need to also declare it extern so people aren't, well, it knows not to define each file. Okay, all right. So now we're going to the fixed camera, and as you can see previously we were actually making a separate perspective and transform and then multiplying them together. Instead we are going to be, we're going to take this multiply out of here. We're going to get rid of these two, and we are basically just going to put it straight into here for the camera to combine itself. It's something we would have been doing anyway. This actually deduplicates some of our camera logic slightly. Okay, so what we should now be able to do is take our projection matrix and then slip the shake rotation in between the projection matrix and the camera's own transform matrix. So we should get the correct rotation after doing this. Let's find out. I changed the header file. Why did I do that? Come on, you can do it. Okay, let's see if that fixed anything. And that has indeed fixed everything. We're now getting the shake correctly inserted between the main and the between the camera's transform and projection matrices. Okay, next up, I need to add a shake header and a similar almost. Or do I? You know, I'm just going to put it in here. I'm going to basically put a function here where you can basically just say how much you want the camera to shake for how many frames and in which direction. Yeah, that's basically going to be it. I mean, it is feasible that you'd want, like, say, one camera shake to kind of like override another or to be able to stack them. However, Not going to bother supporting any of that for that. That's a future problem, I think. So yeah, let's have like a pitch frequency. Let's have a pitch amplitude. So yeah, how fast it vibrates up and down, how much it sways, and let's also have a yaw. You don't tend to have camera shake in the roll axis, which is kind of weird. I just kind of realized that. And we're gonna have just a nice simple linear linear fall off over a number of frames. Again, the exciting bit where I write all the documentation. I don't know if I don't do it now, I'll never do it. Okay, how are we doing for time? We're already a quarter of the way through the session and we're not even gotten to the dialog system. Okay. Camera will pitch in radians per advance. That'll do. Yeah, I might want more options here later on to kind of like say have shakes that stop abruptly. That's pretty common. This would be more for kind of like impacts and stuff, which tend to have that kind of like roll off on them. Okay, almost there, almost there. Next up, we can put this into here and all right, nice and simple, nice and simple. We just need to basically copy all of these parameters to variables here so we can use them when we're calculating the camera position. Nice and simple. Do it fast, do it fast, do it fast. Cloudflare just sent me an email notifying me that 5.4 megabytes has been transferred out of my domain since the start of the month. And I'm like, your email probably wasn't much smaller than that. They do great stuff, Cloudflare, anyway. Almost there. Okay, that's good. Next up, we need to actually calculate the how much we're going to shake. I should probably also have a function to stop it. That'd be good. Oh, actually, I'll make the camera destroy do that. That would make sense. Let's move this all the way up here. No, I'll make it its own function. And we're just going to make the duration 0 whenever you do that, because that'll be the default. We need to handle this anyway. Nice and simple. So now we need to figure out how far through the shake we actually are. Let me think about this. Okay, right, good. No, what am I doing? Yeah, so if the camera's shaking, we do our logic there. Otherwise, we're just going to do the old functionality of just multiplying the projection and the transform matrix together to make our final matrix. So all of this we're going to copy into here. Okay, then we then calculate the progress through the current shake. I've got a tiny strip of that rotating room visible down the side of my window, and it's making me a bit nauseous. Okay. So we have the number of frames we've advanced. So now which one are we doing here? This is the pitch, isn't it? Pitch frequency times by pitch amplitude. And then we're going to do the same thing for the yaw. Nice and easy. Split this out over a few lines, given it's getting kind of long. And then I'm going to quickly deal with something that just came up. That's better. Said it was going to be faster, didn't I? No rotation on the roll axis, no scaling. Produce our matrix, and then we're going to put it all together. Okay, that should just work. Should do. Let's go back into... Let's not go back into that just yet. Let's go into a test script, and let's do a camera shake here. Have to include our camera file here. Yeah, in theory, I could have it much more advanced than this. I could have it see how it looks like, say, a whole separate system for being able to, almost like a transition system for camera shakes. For now, this will do. And later on, if we need something a bit more advanced, we can do that then. So what was the frequency we put in here? Oh, hang on, I've just realized the frequency is actually kind of wrong. It'll do. It's not actually a frequency, but it'll do. And our amplitude was quite low. Let's also roll in as yaw and make sure that works too. And I've just realized I didn't actually multiply the amplitude by the time it's been on, so it'll just be a full blast shake for a whole 120 frames. So let's see how that looks. Probably quite horrendous, I imagine. Okay, here we go. So completely okay, and then the second he hits the window, nothing happened. The worst kind of bug, nothing happened at all. So we're definitely calculating a camera shake here. It's because we're dividing it. And then we're just going to divide the progress. Hang on, multiplied by the progress. And it's going to be the inverse progress, as it's going to get lesser as it goes along the camera shake. Okay, shake the camera, dude. Hit that window hard. Hey, that worked, that worked. I'm just going to try it with only yaw and no pitch and just see what happens. And I'm going to exaggerate it slightly because we have the camera rotating along yaw anyway, which might make it hard to spot that it is yawing. There's a lot of additional complexity you want. Like maybe you want the shake to slow down as it like tapers out. Hey, it worked. Okay, excellent. So let's put the shake back the way it was and then delete out the yaw. We don't want any of that. And then we're going to put the fixed camera back together mostly. Yeah, let's take these out of here, put them in here. Just undo all this hackery I just did. Okay, it's now mostly back to normal. Let's do a build and make sure I didn't break anything. Okay, camera's completely still. Hey, that was pretty good. Let's adjust the parameters a bit on that. So let's make it slightly less aggressive in terms of how much it moves, because I feel it was maybe a bit too much. And let's speed it up slightly. Let's go for, say, 3.5 times as fast. Just like more of a vibration than, like, say, an earthquake. Ah, okay. Very small, subtle vibrations don't really work with an integer-based renderer like this. You barely notice. So let's increase it slightly. It might also have been kind of like an aliasing artifact where, say, our camera shake was aligned with the frames. We'll find out later. That looked pretty good. I'm happy with that. Let's cut the duration down and speed it up a bit more. Let's go for just 1 radian per frame. Okay. Bit slower tail off than that. That was a bit too fast. One of the things is because of the integer rounding on the renderer, you don't actually notice it tail off very much. Hey, that's pretty good. Maybe slightly less than that. Some of these things you just have to watch it back a bunch of times and tune it to exactly what you're kind of looking for. That looks pretty good. I feel like the maybe linear isn't the best for the tail, but that will do for now. We spent way too much time on this insignificant feature. Oh yeah, those comments I need to actually commit those. Camera shake. And let's commit those comments. Okay, the dialog system I actually promised at the start of the stream. So the way I'm thinking about doing this is having another component, kind of like the mesh component, but it basically allows you to attach an image, because we have this sort of image, not class, but type already, an image to a point in 3D space in the scene. And then having kind of like a helper that pre-fills the image with a dialog box. Now we don't have any dynamic allocation, so I'm basically just going to create some images of roughly large enough size. Like, for example, I can't imagine anyone wanting a dialog box bigger than, say, that. That would be kind of silly. So yeah, I guess that'll do. Entities, here we go, components. Let's get rid of this here. I'm not using this folder for anything. And I'm going to actually use the mesh component as a base, because obviously 99% of the functionality is already there. So what are we going to call these? Because it's not just dialog boxes, it's any kind of 2D UI. In fact, I actually thought this is kind of a weird question, is that when something's attached to a point in 3D space, like say a compass marker or something, it's a bit different to stuff stuck to the camera. And I'm not really sure we have a good term for that. Yeah, there is definitely a difference between, say, like the marker over a character's head indicating that you're targeting them in a character action fighter versus the text in the corner. They're different, but they're also both 2D UI. It's I don't know. Let's call it an image overlay component. That is word salad enough that it'll probably do. So every instance of mesh in here needs to be gone. Let's start out with all the ones that are in capitals. That'll be quite easy to find. And let's go into here. Okay, that's that sorted. Oh my god, there's a lot of things to do. I'm not going to have many of these on the screen, I don't think, so I'm going to go for 8. Also, they're going to take up a lot of memory because we're going to be having some large buffers and probably only using some of it. It's a number of... let's just go through and find and replace all these. I don't like using find and replace because it's very often you make mistakes by doing that. I like just being able to, you know, look some text in the eye before I eviscerate it. Okay, that should be good. We don't need to be able to set meshes or anything really because, oh, but we do need to be able to get the image. So I might, yeah, it gets the image rendered by, yeah, let's make a thing so you can get the image out and then you can draw to it using any of the existing drawing tools. And I'm going to add a remark to this because this is actually going to work similar to the mesh queue in that it's going to be a dense array. So deleting something with a mesh component will actually shuffle the indices around. No, actually, I've changed my mind. I'm not going to do that because that would actually involve copying a whole image back and forth. You know, whereas like shuffling like a list of mesh pointers, not that big a deal. Kind of a big deal to do that with something like say a big bitmap image. So yeah, so rather than having a parameter, it's going to return image which the overlay component will layer. Yeah, okay, that's nice and simple. Right, location versus position. What's the difference? I've forgotten. My God, these words are confusing me. Whatever. This language is too confusing. I'll just reuse this word here. So yeah, so we're going to have a point in 3D space, and I'm thinking I'm going to center the bottom of the image on top of the point that you've specified. Let's get rid of this transform, don't need this anymore. Good. All good. All good. Ah! Yeah, so not going to be using set transform, but we're going to turn it into like a position update so we can move the object around once we've placed it. Ah! Can't type. Okay, so we're probably not going to get the whole dialogue thing in today, but we can probably get some images displaying over people's heads. So that'd be good. Again, could use find and replace. I just want to be able to see what I'm changing. And get rid of that. No, we're going to leave that set mesh. We're going to turn it into a get image. And this is going to get slightly confusing because we're going to have, you have component IDs, right? Which are the things you actually attach to an entity. They're basically there for kind of disposal purposes more than anything else. And then we're going to link the component ID to a position in the queue and the position in the queue to an image. So there's actually two levels of indirection here. I love making things as complicated as possible. All right, okay. So import the right file, that helps too. We need the image, we do not need a matrix or anything like that. We do not need cameras. Yes, we do need cameras because we need to turn the point in 3D space into a point in 2D so we can overlay the image. Another thing I'm going to do, because otherwise I will forget to do it, is I am going to overlay the images here. And they're going to go underneath the transition, that would make sense. And I was originally tempted to make these kind of like somehow mixed in with the opaque mesh components, but they're different enough that it just wasn't worth the complexity. Okay, so maybe I don't do the compaction because I'm going to be doing kind of like a jump anyway. And we're not going to have many of these. No, I'll leave it in there. I'll leave it in there. What the heck? All right, so just thinking about the best way to actually do the to actually define the images. I'm gonna have to come back to that. I have to think about it. We can get rid of this. We don't need this anymore. Now, does it make sense to, even though I try and avoid, yeah, it does. I try and avoid like doing anything that looks like a row structs because quite often you're only working with kind of like one sort of column of a table, if that makes sense. And you don't really want stuff being paged into the CPU cache that isn't... As a matter of fact, this entire game would probably fit inside the CPU cache of a modern CPU. You don't want stuff being pulled in unless it's part of the active operation. Okay. So I think it makes sense to kind of group this together. Yeah, that'll do. Let's grab all the arguments from here and paste them into here. That's not the correct, that's not, Just copy the parameters out of completely the wrong function. That's what I do. Yeah. Leave that there for now. To do set an image. To do find a free image. To do free the image. I might change these pointers into indices just so I can more easily do a search for values that aren't there yet. Or maybe I just have like an array of balls and just mark them as true. So I just basically go through and go like, I found a false at like the third item. That one's free. Yeah, I might do that. Okay, so we've got the set transform. We are going to change that to set location. And we're going to do something very similar to this. Easy. And I'm actually just going to copy this up here. I mean, it's unlikely to make a performance difference. It's just a bit cleaner. I'd be very surprised if the compiler didn't like do what I'm doing right now by itself, but it's just a bit cleaner. Right, so we're never going to set a, we're going to set a location instead of a transform. And we're not going to set a mesh, we're going to get an image. So let's copy this to here. And how many are we doing here? We're doing 8. Okay, look away, everyone. I'm about to do something horrific. So, if you actually have a look at the kind of macro that defines an image, it's actually not that complicated. It's basically an array of colors. Oh, it's just occurred to me, I should probably document in here. The image will never have. Because images can both have depths, so it's kind of like the frame buffer, but they can also not have depths from almost everything else. So document that they will not have depth. You can't use them as render targets. Yeah, so basically we need like an array of colors, and then we need basically an image is like a struct that basically just, turns it into something useful. Let's set a sane number of rows. So our display is 180 rows, so 120 rows will probably be enough. You'll never want a dialog box filling the entire screen. Nice and simple. And we're going to do the same for the columns. And our resolution is 320, so let's go for 150. I'm going for something really, really just weird here. There's no rhyme or reason for those values I just picked. I just picked them. Right, so I'm going to make a single, absolutely massive array. Yeah, that's what I'm going to do. Let's go import. We'll probably have the colors on the basis that we imported images, but I'm going to import the header anyway. So we're going to want to get the number of images, multiply it by the number of rows and columns in each image. And that should be good. Right. And this is no longer going to be a pointer, it's going to be a straight up array. Right. So we are going to dynamically point to a part of the colors array from here. This is horrendous. It will probably work though, and it should be fast, which is what we care about. Okay, so we freed the image there, that's good. It's not happy with that. Why is, oh, I made an array of images rather than, yeah, indices of images. Okay, next up, we need to come to here and we need to go find a free image. So we should definitely have one. So we've made that component. We've recorded the component ID. We need to now go through our list of, yeah. Naming here isn't perfect, but gotta go fast. We call it indices, didn't we? Yep. And we're also going to initialize the image here because we're getting the image out, but we're not really, we've never actually defined what's inside this structure. It's all going to be zeros. So we need to actually put something in it. Is there a better time to do it than when we actually create the component? Probably not. I could use like flags or something to record that I have done it, but honestly, checking and setting the flag and stuff will probably cost about the same. It's just always writing the values. Yeah, as marker is used. So we know not to hand out the same image twice unless it's no longer in use. And then we need to actually initialize this struct here. Yeah, that should be nice and simple. So it's going to be open some brackets and write some values in there. What's in one of these? Okay, rows, columns. So, and then our color data. So that's going to be pointed to our shared colors list. We take the image index and then we're going to multiply it by the number of rows and number of columns. So we're getting the right position. Basically, all of the images that you can overlay on the screen at once are all basically just one huge image. And then we're basically like making kind of images that take sections of it. And we're going to import a header to get null. So many things that are kind of funny about C. Like it doesn't even have a Boolean type or null by default. You have to import things to get those. What do you expect in an expression? That's an expression, isn't it? Fine, I'll do it. Field by field. What year is it? Good question given I'm using C99. All right, so that do you mean it must be a modifiable L value? That's modifiable, isn't it? Fine, fine, we'll go back in with the making an object and, well, an object style initializer. I guess I have to cast it? No? Why isn't that modifiable? What? I'm legitimately confused. What was it on about? How is that not modifiable? It's an array of structs. How could it not be modifiable? It's not const or anything like that. It's just a struct, see? There's nothing weird about that. I don't know. Come back to that later. So next thing we need to do is with the camera. Yeah, we've got the camera. Do we have the matrix in here? No, we don't. So let's bring that in. And I think I've got a transform. There it is. Yeah, so basically we give it a location on the x-axis and y-axis and z-axis. But you're going to read through this in a nice kind of like continuous stream just to get all of our location axes out. Wait, that's not the function we want. That's making a transform matrix, not applying a transform. Ah, yeah. That's right. I remember how this worked now. So what we actually want to do is matrix image. Yeah, I made this function where you give it an image and it would basically kind of, it would give you the location in the image. So I'll be importing, yeah, we're importing the video buffer. We can use the video buffer as our image. So, shot myself in the foot. Okay. That takes an array, so we can give the location that we brought in. We can then use the camera matrix and we use a video buffer as our image. And then it will give us the row, the column, and also the depth. Right, yeah. And it doesn't round to an integer, but that's fine. We don't need the depth for basically just using it because we need it. Well, because the function requires it. That's fine though, we'll be calculating it anyway. The compiler will probably throw that away for us. It's good like that. Right, so if we get a valid number for the row, then for now, I'm just gonna make it throw an error. That will probably confuse me when I actually finally compile this code and run it. Normally does. What is this talking about? Let's just try building it, see what happens. I've changed the header file, it needs to be done more quickly. Right. Oh! I understand why that's happening. I declared these consts. I'm just going to remove those, honestly. Just for the sake of getting this done more quickly. We know not to modify those. Okay, what's broken now? Fine, I'll put it back in. Now you're happy? Now you're happy. Now we shouldn't need to do a make.j anymore because we're not editing header files. Oh yeah. And dead simple. Got the image, we can return it. I'm also just going to document in here that it's not going to automatically clear the images because there's a, we might want it clearing transparent, or we might want it clearing with a certain color or something. We don't know. So it's best to leave it kind of like whatever garbage is in it for performance. Okay, this isn't happy about something. What's this not happy about? Color initialize float with. Fine. It's a trust me bro moment. Actually, I'm assuming that an array, kind of like a two-level array, they're going to be packed together, right? There's no way there's going to be any kind of like spacing between the sets. I changed the header file again. I forgot. So while that's compiling, let's just import our image overlay component here. And let's add one just at the start. And we're going to attach it to the protagonist. And we are just going to use these coordinates here. Those will probably do. We will need to update these every frame if anyone's moving around. Oops. Protagonist dialog. Image, that'll do. Now, it might have made sense to like return the image out, but I'm thinking not. You can get it all using the component. So let's just draw some rubbish to the image, I guess. Let's clear the colors. Have we actually imported images into here? No, we haven't. We're going to add some helpers to do this later on. So we can clear it. Have we imported the colors as well? Again, we probably already have it for importing images, but it doesn't hurt. And then let's just draw a rectangle in the corner. Oh, actually, what we could do is we could just grab the pointer graphics. Yeah, let's grab the graphics of the mouse cursor. That will actually do, just for the sake of testing. So we're going to layer an image onto our image, and we're going to use the cursor image that we just imported, and we're going to put it in the top left corner, and we're going to layer it onto our dialog image. Right. Let's watch it crash, everyone. Yep, it crashed. Apologies, I still haven't deleted that keyboard shortcut. It crashed for the reason we expected. Let me just pull this up. It crashed because we hit our drawing something callback. So what we can now do is we can layer our temporary image. Yep, we can grab our image out just by doing this. And then we can layer it onto the video buffer at the row and column specified. Now this is at the moment actually going to be between the protagonist's feet, not at his head, so we're going to have to fix that. I did have an early version that said the component system had like a look target, and I was going to use that for attaching dialog boxes to, but I've since removed that. It was probably a massive error of judgment, to be honest. And video buffer. And let's just dereference that pointer. Why doesn't it like that? Oh, yeah, because I'm dereferencing well, making a pointer to a pointer rather than grabbing a pointer, which I actually wanted. And there we go, we've got a mouse cursor at the guy's feet. That actually worked. This actually has me a bit worried. Things don't normally work that well. Does it move when the camera shakes? That'll be a bit of a test. Yes, it does. Aha! It's all working. It's all coming together. Yes. Okay, so the next thing we need to do is we actually need to... we kind of need some alignment tools, realistically speaking. We need the ability to kind of like position things correctly. At the moment, everything's going to be... I'm trying to figure the kind of things you want to actually draw using this tool. Some of them you'd want it centered. Some of them you'd want it kind of like centered to the bottom. So if you're thinking about things like, say, think about the compass marker in Halo, right? You'd want the image centered on the thing that you're using. However, for something like a dialog box, you'd want it immediately above the object that you're attaching it to. So for now, I'll just make it above, but later on, I might add a flag that allows you to change how it's positioned. So get the row, and then we're going to subtract the number of rows, and get the column, and subtract the number of columns. So by 2. Now this is going to make our object disappear. Or not. Yeah, so that's in the top left corner of roughly where our image is. That looks about right. So yeah, I'm going to... Is there anything more I can do with this really in the next couple of minutes? Let's just get this committed. Do anything with any of these, did we? I'm getting really bad for just having tons of sort of hacks in my files rather than, you know, cleaning things up, but we'll figure it out. So yeah, let's add a nice, helpful little bit of code for a dialog box. I'm not really sure where this belongs. Maybe I'll just put it in there with the image overlay component. I mean, like, it's going to like bloat this file out a bit, but is that the end of the world? So I did actually have a mock-up of what I wanted dialog boxes to look like in this game. However, I lost it. So you're just going to have to imagine it. But I'm basically going for a very simple kind of like black box, kind of purplish border, purple kind of like header bar, and some text inside it. I've already made the font. So yeah, I guess that's what we'll be doing tomorrow. Thank you very much for watching, and have a great evening.